Welcome students, let's begin with the topic of magnetic field due to current carrying conductor. So in this topic we'll understand how does a magnetic field looks like in a current carrying conductor. In the previous session we've already discussed that how Oersted he explained that a current carrying conductor or a current carrying wire is magnetic in nature. It shows magnetic character. In this topic, we'll understand how magnetic field lines looks like, how is their shape, how do they vary with the current carrying conductor. So in this activity, the aim of the activity is to study the variation of magnetic field upon reversing the, we are reversing the direction of electric current in a circuit. What is happening? In a circuit, we are placing the magnetic compass to see the direction, and then we are observing how the deflection changes when we are reversing the current. So, with the help of the animated video, we will study this activity and have an understanding of this activity.
Take a magnetic needle and pivot it on its stand, such that it is freely pointing towards north and south. Take a thick and long insulated copper wire and connect it to a battery through a switch and a variable resistance. Hold the wire above the magnetic needle such that the wire is parallel to the axis of the magnetic needle. Switch on the current. It is observed that the north pole of the needle points towards the west as long as the current is flowing through the wire. Furthermore, if the magnitude of the current is increased by decreasing the resistance, the deflection of the magnetic needle increases till the north pole of the needle points towards exact west. If the wire is held above the magnetic needle such that current is flowing from north to south, then the north pole of the magnetic needle deflects towards the east. If the wire is held below the magnetic needle such that the current is flowing from south to north, then the north pole of the magnetic needle deflects towards the east. If the wire is held below the magnetic needle such that the current is flowing from north to south, then the north pole of the magnetic needle deflects towards the west. Conclusion from Oersted's experiment. Any conductor through which a current flows behaves like a magnet. The strength of the magnetic field depends on the current flowing through the conductor. That is, more is the current, more is the strength of the magnetic field. The magnetic field set up by a conductor acts at right angles to the direction of the flow of current. The direction of motion of the magnetic needle depends on the direction of the flow of current and the relative position of the conductor with respect to the magnetic needle. Rules for the determination of direction of motion of the magnetic needle. Ampere's swimming rule. Imagine a swimmer swimming in the direction of flow of current and always looking towards the needle, such that the current enters from his feet and leaves from his head. The direction in which the left hand of the swimmer points gives the direction of motion of the north pole of the magnetic needle. Snow rule. The direction of motion of the north pole of the magnetic needle can be found out by remembering the word snow, where S stands for south, N stands for north, O for over, and W for west. Thus, if the current flows from south to north over a magnetic needle, then its north pole turns towards the west. From the above rule, it is clear that if the current flows from north to south over the magnetic needle, then its north pole will point towards the east instead of west. Similarly, if the current flows from south to north under the magnetic needle, then the north pole will point towards the east.
So after watching the animated video, we will see what all observation you made in the activity. The first is when the key is not plugged in. Okay, this was your key, this is your key. When this key was not plugged in, when the key was open, the circuit is incomplete, right? Current will not flow, and if the current is not flowing, this is like just like a wire which does not have any current. So what will we observe? When the key is not plugged in, the compass needle, this compass needle over here that you see, remains stationary in the north-south position. See, this diagram shows the deflected one, but when the key was not plugged in, when the key was like this, the compass, it showed like this, north and south. Okay, there was no deflection in the compass. Next, once the key is plugged in and the current starts flowing through the copper wire from north to south. Now, in the first case, what is happening? The current is flowing from north to south. See, this direction is very important when you are studying the magnetic field, because you've already seen that how by changing the direction of the current, only by changing the direction, the magnetic field deflection, it changes. Okay. So, when the current is in north-south direction, can you see the diagram over here? This is your north end, this is your southern end, this. And how is the current flowing? It is flowing from north to south like this. Positive terminal going like this, and this is the direction of current. When the current is from north to south, the needle shows deflection towards east. This is initially the needle, this was the magnetic compass. When the key was not plugged in, this was the direction. After it was plugged in, the needle got deflected like this in the east direction when the current was from north to south. Okay. When the direction of the current in the copper wire is reversed from south to north, okay, we are reversing the direction of the current by reversing the terminals of the battery. We have reversed the terminals of the battery. Look at over here. The terminals of the battery, positive terminal is towards the east, negative terminal is towards the west. So, in this case, the current goes from north to south. Okay. But on the other hand, we have taken our negative terminal towards the west and positive terminal towards the east. As a result, our current direction is from south to north. When we have this type of current direction, the deflection of the magnetic needle compass is towards the west. Okay. In this case, the deflection was towards the east. In this case, we are getting it towards the west. This is a direct relation between. So, this proves that whenever we are reversing the direction of the current, the direction of the magnetic field so produced by the current carrying wire is also reversed. Okay. Thus, what is the learning from the activity? What is the learning from the activity? This shows that the direction of magnetic field produced by a current carrying conductor reverses. It reverses by changing the direction of electric current through it. Okay. So, what will be your conclusion? Okay, direction of magnetic field depends upon the direction of the current. Okay.